All right, let's talk about one of those small, infuriating, but actually super interesting mysteries of everyday life. We are diving deep into the physics of falling toast.
You know the moment, that slow motion disaster as your breakfast makes a break for the floor. It seems to have a mind of its own, doesn't it? And it always chooses to land on the worst possible side.
Yeah, it feels so predictable. It's like it's a law of the universe, right? Like Murphy's Law, but specifically for toast. But what if I told you it has absolutely nothing to do with bad luck and everything to do with cold, hard physics?
Okay, so let's get into it. To unravel this whole mystery, we're going to use this one single, incredibly powerful tool. A chart. A chart that can actually predict how something will fall and land after it tumbles off a table.
And here it is. Now, I know, it might look a little complicated at first, but trust me, this chart holds all the answers. Think of it like a treasure map for understanding exactly what happens when your toast takes a nosedive. So, to make sense of this thing, we just need to know the three key ingredients. We've got H for drop height, H for the height of the table, and R for the clip radius. Now, clip radius just means how far from the center the toast catches the edge of the table. That's it. Those three things decide everything. Let's look at the axes for a second. The vertical one on the left isn't just height, it's the drop height divided by the table height. And the one on the bottom is the same idea. It's the clip radius divided by the table height. The genius here is that this makes the chart work for any table because everything is measured relative to how high that table is. Now for the fun part, these colorful, curvy lines. This is where the magic happens. Each one shows you exactly how many times the toast is going to spin before it lands. So that pink line is half a turn, orange is 1 full turn, green is 1.5 turns, and so on. All right, so now we know how to read our map. Let's use it to finally solve the butter side down paradox. So let's picture the classic crime scene, right? Your toast is sitting there, butter side up. It gets nudged, it slides, and the edge just catches the side of the table on its way down. That little clip is what kicks off the entire rotation. So, where are we on this chart? Well, look for that vertical black line that's labeled toast. This line represents a pretty average piece of toast, with a normal clip falling from a totally standard 1-meter high table. And here it is. This is the big reveal, the aha moment. If you follow that black toast line up, where does it land for most of the drop heights? Bam! It hits that pink curve almost perfectly. And what does the pink curve mean again? Yep, exactly 1/2 of a turn. So if your toast starts butter side up, and it does exactly half a rotation, well, you know how it's going to land. Butter side down. It's not a cosmic conspiracy against you. It's just the most likely physical result, all thanks to the height of our tables and the size of our toast. Okay, so we've cracked the code on why it happens. But what if we could use this knowledge for good? What if we could use this chart not just to understand failure, but to actually engineer success? This leads to a pretty fun idea, the Kitchen Olympic Challenge. So here's the challenge. Could you, on purpose, drop a piece of buttered toast, let it clip the edge of the table, and still manage to make it land butter side up? Could you bend physics to your will? The gold medal in this event, the ultimate goal? Not one flip, not two, but a spectacular, jaw-dropping triple somersault. And you know what? Our trusty chart shows us exactly how to do it. If you want to nail 3 full rotations and land butter side up, you'd have to set up your drop so that it lands right on that deep indigo curve. It would be tricky for sure, but the physics says it's totally possible. So as we wrap this up, it's really important to realize that this whole thing is about so much more than just a kitchen accident. Yeah, what we've been looking at here isn't some quirky toast law. It's a fundamental principle of how things rotate when they fall. It's universal. And here's where it gets really, really cool. This whole result, it's independent of gravity. That means you could pull off that triple somersault toast flip right here on Earth or on Mars or on any planet, and the physics would still work. Your slow-mo success video could go viral across the galaxy. And of course, this isn't just for toast, right? The exact same principles apply to your smartphone if it slips off the table, or a book, or pretty much anything flat that clips the edge on its way down. This chart is basically a guide to the physics of everyday clumsiness. Which leaves us with just one final, and let's be honest, probably the most important question. Now that you know this chart is a playbook for avoiding breakfast disaster and for achieving kitchen Olympic glory, are you ready to frame it for your kitchen wall? Good luck with the challenge.